Alright, and now we'll be discussing the first problem, which is a simple pendulum problem. We are going to establish the Lagrangian and the equation of motion for the simple pendulum problem. Okay, and this is the most simplest problem while solving Lagrangian based on Lagrangian. And here we have a pendulum which is attached at a point C and with a string of length L, and this is specified with the generalized coordinate theta. Okay, here we have theta as the generalized coordinate. Okay, and because theta is sufficient to describe the system. Okay, you don't need any xy coordinate because theta is more than sufficient to locate the bob or locate the pendulum, right? So in order to find the Lagrangian, we have to write T, and T is nothing but kinetic energy and V is the potential energy. In general, T is equal to half mv square. Okay, and T is equal to half mv square. V is the velocity. Here we have the displacement is given as S for the given bob. Okay, so we can write S is equal displacement is equal to L theta here, and here L is the fixed one, that is the length of the given pendulum string, which is L is fixed and theta is varied. So once we have to find the velocity, we have to find the first derivative of this displacement. So we will be having V is equal to L theta dot. So we need V square here. So we need to find V square. So V square is equal to L square theta dot square, which is T is equal to half m L square theta dot square, right? And once we established this, we are set with this kinetic energy. Next we will be having we have to find this potential energy, and in general we have here acceleration due to gravity is involved. Here the height is given as OB. Okay, this is given as with the help of this pendulum we are going to find the uh, potential energy. So mg is here and OC is nothing but the length from the center of the pendulum to bob to the point where it fixed minus BC. BC is nothing but the distance between the string and the end of the string and the starting of the string. Okay. So initially, so MGOC is nothing but L and L cos theta is nothing but BC. So once we have this, we can establish V is equal to MGL into 1 minus cos theta. Okay, we are set with this potential energy also. Okay, and now we can write this Lagrangian. So Lagrangian is nothing but L is equal to T minus V. L is equal to T minus V, right? As you know, L is a function of Q dot T. As I said, Q is the generalized coordinate, Q dot is the generalized velocity, and T is the time. And L here we have theta as the generalized coordinate, theta dot as the generalized velocity, and T is the time. Okay. Since we are not using time explicitly, this Lagrangian will only consist of theta and theta dot. T is not is mentioned implicitly. You can't find any T in the Lagrange. So here we have L is equal to T is nothing but this one of m L square theta dot square and minus mgl 1 minus cos t. Okay, this is what the Lagrangian is. Okay, Lagrangian for the simple pendulum. Okay, once we have this, we can use this Euler-Lagrange's equation now to get the equation of motion. Okay, so here we have L, so we can write Euler-Lagrange's, right? Euler Lagrange's equation is nothing but d by dt of dou L by dou q dot qi dot minus dou L by dou qi equal to 0. Here we know that generalized coordinate is nothing but theta here. So d by dt of dou L by dou theta dot minus dou L by dou theta. Here I am solving in step-by-step manner. So you don't need to write this while solving this problems. Okay, what we need is we are going to find the equation of motion. Then we will be getting that. Okay, so here in order to make it more clear, I will be writing this equation. So once we have L we can know that T is a function of theta and theta dot. So L is a function of theta dot. So once we have this, with the help of L, we can find dou L by dou theta dot. What is dou L by dou theta dot? Which is nothing but ml square theta dot. Once you differentiate theta dot square, you will be getting 2ml square. Okay, you will be getting 2ml square, and this 2 and this 2 will cancel. We will be having ml square divided by ml square theta dot. And here in this equation, in this part, we are having theta only. So we don't want to use that term now to as a part of this dou L by dou theta dot. Then we will be finding dou L by dou theta. Here we will be using this term, that is mgl 1 minus cos theta. So in this first part, that is mgl 1, this term won't contribute to you, but this minus mg minus mg L is there, and once we have this cos theta, we have to differentiate that. You will be getting sine theta. So this is what dou L by dou theta is. We found what is meant by dou L dou theta is, and dou L by dou theta dot is, and we have to find d by dt of dou L by dou theta dot, which is nothing but d by dt of ml square theta dot. Here m and l are constants because m is the mass of the given ball and l is the length of the pendulum, and theta dot is the generalized coordinate. So we will be writing this as ml square theta double dot. Okay. This is nothing but d by dt of dou L by dou theta dot. This first part, right? And second part, we know that minus mgl sin theta. Right? Once we have this, we can substitute for this one, right? So we can write, instead of d by dt of dou L by dou theta dot, we will be using ml square theta double dot, and here we have minus here, right? And here we have another minus here, so we will be getting plus mgl sin theta equal to 0. Right, so here we have m in common, so we can strike that, and l 1l in common, we can strike that, so we can theta double dot plus g by l sin theta equal to 0. So in the case of oscillations, we make sin theta equal to approximately equal to theta because the angle is very minimum. So we can make this equation as theta double dot plus g by l theta equal to 0. Please note this is the equation of motion, and this is the second order differential equation, right? And with the help of this, you can find the time period of the oscillation, which is nothing but t is equal to 2 pi root of L by G. Okay. So this is the technique, or this is the process in order to get the equation of motion from the Lagrangian, from the given Lagrangian of a system with the help of Euler Lagrange equation. Okay. If you want any clarification, please comment. If you like this video, please like, comment and share. Okay. Thank you.